Okay, hello guys. Today we are talking about vector arithmetic, the second lesson of vector. Okay, so let's move to the first part about the vector. So first, here we are just talking about for the scalar multiplication. Okay, so that means a number times a vector. Okay, so here is a blue vector. You can find here is a blue arrow and it represents for v. Okay, maybe v is a vector. And here on the right, there is a red arrow. Okay, we can say it's 2v or 2 times v. Okay. So we can say here, on the left, the vector can be represented for the 2, 1, right? Because from the original to the end of the point, you can say first it moves to the right for 2 units and then moving upward for 1 unit, okay? So we can say vector here equals to 2, 1. And also, in the second vector, we can say here, the vector 2v can be represented as 2, 2, 1, right? And here you can find the vector here exactly moving to the right for 4 units and then moving upward for 2 units, okay? So that can be written as 4, 2, okay? That is for the scalar multiplication right here, okay? And then we can say vector also has addition, okay? So like example for x1, y1 vector plus x2, y2 vector, okay? We can say here, it's equals to x1 plus x2 equals, and also for y1 plus y2, okay? So here's example like a equals to 4, -2 and b equals to -1, 5. We can say here a plus b equals to 4, -2 plus -1, 5, okay? That can be written as 3, 3, okay? That is a plus b, okay? And also we have a vector addition. So you can just consider the geometric representation here for here can be considered as the maybe you're taking a plane. Okay, so maybe you're taking a plane to have a trip. So you can just traveling from A point to B point or traveling from the city A to city B, right? Also, you can choose to taking a round trip, right? You can first traveling to the city C and then going to C to B, okay? So we can say here, so vector A plus vector B, just like from the city A to city C, then you take a trip to city B, okay? That's like a round trip. But it equals to from the city A directly moving to city B, okay? That is a vector addition right here, okay? So we can say here, A plus B, that you can use a tip and tail rules. So first is from the A's tip and to the vectors tail, okay? And then from the tip and to the tail, and added together is from the beginning tip and from the end this tail, okay? That is a vector addition right here. Okay, and also we have vector subtraction. Okay, so you can just consider here, like a minus b can be considered as a plus negative b, okay? So for example, like we have vector 5, 3, and then minus vector 2, 6. So we can say that here is 5 minus 2, and also the y-axis equals to 3 minus 6, okay? That is it. So the final answer is 3, negative 3, okay? So if you want to draw the a minus b in the graphically, okay, so we can say like first you can draw the phi 3, right? So here's for phi 3. And then you can just draw 2, 6 in another direction that is for -2, -6. Okay, so you can consider here as phi 3 plus -2, -6. Okay, so that is for this vector. Okay, so you want to add the red and blue, red and purple vector together. So you can just move in the vector to a new place. Like here, I'm using a green vector to represent for here. Okay, you can find they're parallel with each other, and their side or their magnitude are the same with each other, right? So you can say here, from the O point to A point to B point, we can just connect it from OB directly, okay? That is a vector subtraction right here, okay? So if you want to just trying to represent for like here using a small arrow like AB, okay? So we can set here AB can be represented as first we going from A to O and then from O to B, okay? Please remember that AO is opposite to OA. So we can say AO equals to negative vector OA. So vector OA is A, so here is for negative A, and vector OB here is B, so it's plus B. Or you can also set here, the vector can be written as smaller b minus smaller a, okay? That is it. So here's some deliberate practice for you. You can just try to solve the problem on yourself. But if you want to follow with me, you can keep on going, okay? So let's move to the first problem here. As a first calculate p plus q, okay? So here p plus q, we can say that here is for 5 plus 2, and here's -1 plus 5, right? So here is for 6, 4, okay? That is for the first problem, right? Okay, we added the x-axis together and y-axis also together, okay? And for second problem, 3 times r, we said it's a scalar product, right? So here is just 3 times r's vector here is negative 3, 0, right? So we using 3 times negative 3 and 3 times 0, that can be written as negative 9, 0, okay? So for the third problem, calculate 2p minus q. We can set here 2 times 4 negative 1 minus q here is for 2, 5, right? So 2 times 4 negative 1 is 8 negative 2 and minus 2, 5, then can be written as 8 minus 2 and negative 2 minus 5, right? So the value here is 6 minus 7, okay? That is for the third problem, okay? And for the fourth problem right here, we said find the scalars k and m that you obey the rules kp plus mr equals to 5, negative 2, right? So here we can just try to set here k times p is for 1, right? And r here is for negative 3, 0. So it equals to 5, negative 2, okay? So you can say first the vector can be written as 4k k, right? And here it's for negative 3m and 0 equals to 5, negative 2. So the two vectors added together that using the rules because it equals to the 4k minus 3m and the second part y-axis is k, right? Equals to 5, negative 2. So we can set 4k minus 3m equals to 5 and k equals to negative 2, okay? So then we can put k equals negative 2 into the first formula, that is 4 times negative 2 minus 3m equals to 5. So 3m equals to negative 8 minus 5 equals to negative 13. So here m can be written as equals to negative 13 over 3, okay? So here, k equals to negative 2 and m equals to negative 13 over 3. That is for the fourth problem, okay? And for the fifth problem, we can just try to solve it together. So it's a triangle XYZ. So here's a triangle XYZ. So we said xz equals to vector v and xy equals to vector u. And to find yz's vector, like here, find yz's vector. So we can say here, from y to z, you can just consider as first you can traveling from y to x, right? And then you can traveling from x to z, right? So that can be written as y-axis negative u and x-z is v, right? So here is for negative u plus v for the fifth problem, okay? So that's a total exercise here. I hope you can understand it for how to make an addition and subtraction and how to use a scalar product right here. Okay, so that's for our today's lesson. See you next time. Bye.